In this video, we're going to talk about partial fractions and, of course, solve some integrals involving partial fractions. First, I want to say you do not use partial fractions unless the degree of the denominator is greater than the degree of the numerator. You do not use, well, maybe that's not entirely true. First, do the long division. Then, perhaps, you may or may not use partial fractions. But do not attempt to use partial fractions from the get-go if the degree of the denominator is not larger than the degree of the numerator. So here are some examples. Suppose in the bottom you have x minus a times x minus b. I don't care what you have on top, except it better be linear, because the bottom is of degree 2. So you could write this as a sum of two fractions where x minus a is one denominator and x minus b is our second denominator. Since this is to the first, since this is linear, it's to the first degree, what goes above it is 1 degree lower than 1, which is 0, which is a constant. Since that's to the first degree, what goes above it is a constant, to be determined. Now, if instead you had, say, x minus a squared times x minus b, this time you're going to get, you have to build up. You get x minus a to the first. Let's even suppose that was third. Then you're going to have x minus a to the second. And then you're going to have x minus a to the third. You have to build up to the third power. And you're going to have x minus b. Now, what's in here is linear. Notice I'm not taking into account that power. What's in here is linear. So you go down to a constant. Linear, first degree, you write down 0 degree, which is a constant. Let's even make this x squared. In here it's linear, you write down a constant. Here, what's in there is quadratic. So you write a linear, dx plus c. And as long as what's here is not 5, degree 5 or bigger, because when you FOIL this out, you're going to have an x cubed plus lower terms, and when you multiply it by x squared minus b, you're going to get an x to the 5th. These include x squares maybe, and x's and constants. And when you multiply those by x squared, you'll never get above x to the 4th. So the highest, same thing when you distribute the b. You're never going to get larger than x to the 5th. So this question mark has to be degree 4 or lower. Suppose, so let's look at this for a moment. Let's look at this pretty carefully. Again, if you have x minus 2 squared, this becomes x minus 2 to the first, x minus 2 to the second. And since this is linear, you get a. Since that's linear, you get b. Okay, so if you have x squared, now you get to think of x squared two different ways. You can think of it as x if you like, maybe x minus 0 squared. But if you think of it as x squared, then you have to write x to the first, and then you have to write x to the second. X to the first, x to the second. Since this is linear, you write a. Since this is linear, you write b. Now, on the other hand, you might think of this as just, x squared. In which case, you have x squared, maybe like x squared to the first, so you don't have to go from the first power to the second power because it's squared, it's to the first. In other words, for example, if you had x squared plus 4x plus 2 in the bottom, what you would write on top would be, well, don't forget that denominator. What you would write on top would be, since this is quadratic, you would write linear, ax plus b. Because this is to the first power. So since this is quadratic, you'd write ax plus b. And you have every right to say, wait a minute, we're getting different answers. This is not true. If we were, then something isn't really right here. If I multiply the bottom by x and x, then both denominators are x squared, and the numerator will be ax plus b. Ooh, look at this. They are the same. So it's up to you how you think of x squared. Again, if you want to think of x squared as x minus 0 squared, that means something to the second power. Well, then you better have that something to the first power, and then you better have that something to the second power. And since this is linear, it's a, and since this is linear, it's b. And x minus 0 is x to the first, plus x minus 0 is x to the second. You get that. But now, if you want to think of x squared, say, as x squared plus 0 to the first, which it is, so then the denominator is just x squared plus 0, and since this is quadratic, you put linear, first degree on top, and x squared plus 0 is just x squared. And these are the same. That should be x squared here. The reason is, if I multiply top and bottom by x, then everything's over x squared, and the top will be ax plus b. So they really are the same. So how you handle x squared? You have to be careful and think about it. X squared is not a friendly denominator to have, in my opinion. Okay, so let us do a couple of integrals. Suppose you have the integral of dx over x squared minus 1. So there's an understood one here. We really want to write that differently. Well, x squared minus 1 is x plus 1 times x minus 1. So one denominator can be x plus 1, and the other denominator should be x minus 1. Since these are linear, first degree, you put a constant on top for both of them. And now, with these two fractions on the right, you want to get a common denominator. So what you do is you multiply this one by x minus 1, top and bottom, and over here you multiply by x plus 1, top and bottom, and then you get The bottom is x minus 1. Let's say x plus 1 times x minus 1. And the top will be ax minus a plus bx plus b plus bx plus b. And these two fractions should be equal. Well, if two fractions are equal and they have the same denominator, the numerators have to be equal. That is, this numerator must equal to that numerator. Ax minus a plus bx plus b. Just understand that 1 is 0 x's plus 1. How many x's do we have on the right side? Well, here we have a, and we're adding b more. We have a plus b x's. And after all, if you had 3x plus 4x's, I'm sure you'd say that's 7x. But I don't want you to just jump to the answer. Ask yourself how you got the 7. An intermediate step was you added the 3 and the 4. Well, since I don't know what a and b are, when I ask myself what 3 and 4 is, I really can't say 7 because I don't know what a plus b is. But that's what it is. Plus, I hate negative terms first. So I'm going to say b minus a. So they both should have 0 x's and their constant should be 1. That is, a plus b is 0 and b minus a is 1. Well, if I add these two, the a's cancel and I get 2b is 1. So b is a half. And when I add a to b, when I add a and b, I get 0. So a must be negative a half. That way, when I add them, I do get 0. Say a is negative a half, b is 1/2. So we come back to the top. We come back here. Now, we now know that 1 over x squared minus 1 is equal to a was negative a half over x plus 1 plus 1/2 over x minus 1. We just learned that. Well, that's really helpful because I wanted the integral of 1 over x squared minus 1 dx. So it equals the integral of the right side. Remember, the integral over sum is the sum of the limits. I can take the integral of the first term plus the integral of the second term. In fact, I can pull out the constants. We have the integral of 1 dx over x plus 1 plus the integral of dx over x minus 1. Now, when the denominators are linear, it's pretty friendly because if I call that u, then 1 dx is du. That is, I have du over u. This is just, the integral part is just ln of x plus 1 plus a half. And this integral, well, if I call that u, du's right on top. That's just ln of x minus 1. Now, if I factor out the half, I'll have ln of x minus 1 minus ln of x plus 1 plus c. But remember, ln of a minus ln of b, that can be written as ln of a over b. And there's your answer. Using partial fractions. Let us try the next one. Suppose you have the integral of 3 dx all over x squared plus x minus 2. Now you can pull the 3 in the front. I wonder how much that will help. But let us try to decompose this. So 3 over x squared plus x plus 2. This is 3 over. Well, if I try to factor that, it seems like x plus 2 times x minus 1 would work. Yes. So we're gonna get something over x plus 2. Since that's linear, a goes on top, constant. X minus 1, since that's linear, a constant goes on top. Now, we want to get common denominators. So I multiply top and bottom by x plus 1 over here and x plus 2 over here. And I'm going to have the common denominator the same as this denominator, and the numerator is going to be ax minus a plus bx plus 2b. But let me write the 2x plus 2b. Okay. Since the denominators are the same, it must be that the numerator is 3. So what we have is that 3 is ax minus a plus bx plus 2b. How many x's do we have? A plus b of them. What's the constant? If you prefer, negative a plus b. And 3, that's 0 x's plus 3. So that must be 0, and that must be 3. So a plus b is 0. And negative a plus b is 3. Well, if I add them, this cancels out. So I get 2b is 3. So b is 3 over 2. And I know that when you add a and b, you get 0. So a and b must be different signs. Okay, so I have a and b. Negative 3 over 2 and 3 over 2. So it was equal to something over x plus 2 plus something over x minus 1. And it was negative 3 over 2, and b was 3 over 2. So I can integrate this sum, which means I can integrate them separately. And the nice thing is these unfriendly constant fractions can come out in front. Plus 3 over 2, the integral of dx over x minus 1. Well, again, if I call that u, the top is du, 1 du. So I have negative 3 halves. The integral of du over u is ln of the absolute value of u. Plus 3 over 2. If I call that u, well then that's du. The integral of du over u is ln of u. Okay, let me erase this so I can finish up the answer nicely. Of course, plus c. Now, I can factor out as 3 over 2. let me write this first. I factored out the 3 over 2. So I have ln of x minus 1 minus ln of x plus 2. Notice I just didn't write down the 3 over 2 because I wrote it down in front. Plus c. Well, ln of a minus ln of b, this is ln of a over b plus c. There is the answer to that problem using partial fractions. What if you have this problem? The integral is 3x squared minus 7x minus 2 all over x cubed minus x. So we have 3x squared minus 7x minus 2 over x cubed, I'll fix that, minus x. So what we want to do is factor the denominator. Can clearly factor out an x, so then I'm left with x squared minus 1. But I can factor that further. X plus 1, x minus 1. So then it's going to be something over x plus something over x plus 1 plus something over x minus 1. Now before we go any further, notice that the degree of the bottom, 3, was larger than the degree of the top, which was 2. Okay. Since each of these bottoms happen to all be linear, I'm going to put constants. So I want to write this with a common denominator. So right now I have a over x, and I need to multiply it by x squared minus 1. X squared minus 1, top and bottom. Plus b over x plus 1. Well, the b is going to need an x times an x minus 1. At least the denominator needs that. Plus c over x minus 1. The denominator is going to need an x and an x plus 1. I can only multiply by 1. Okay. Now, remember, this is supposed to equal this fraction, which I just wrote below, is supposed to equal this. 3x squared minus 7x minus 2 over x cubed minus x. Remember, these denominators, if you multiply them out, they are x cubed minus x. Okay. So the denominators between this and this, they're the same. The left side has a common denominator and it equals the right side. That means the numerators must be equal. A times x squared minus 1 plus bx times x minus 1 plus cx times x plus 1, it must equal to this numerator. Okay, so let's see what's going on. We have ax squared minus a plus bx squared minus bx plus cx squared plus cx. And this is cx squared squared minus 7x minus 2. Now, how many x squares do I have on the left side? Well, I have A, and I'm adding B, and I'm adding C. That's how many x squares I have. And if in the end I didn't cross out anything, I'll say, oops, I made an error. Maybe I have another x squared. Plus, how many x's do we have? Well, we have negative b plus c x's. What's the constant? Negative a. And this is supposed to equal to this, negative a. So notice I crossed off everything. It's just a little check to make sure that I wasn't sloppy. So this must equal 3. This must equal negative 7. And negative a must be negative 2. Okay. So if negative a is negative 2, that means a is 2. Because if two quantities are equal, if you change their signs, they'll still be equal. Well, if a is 2, then b plus c must be 1. Because we all know that 2 plus 1 gives us 3. So b plus c must be 1. And negative b plus c is negative 7. If I add these, the b's cancel, and I get 2c is negative 6. So c is negative 3. But b plus c is 1. So b is 4. Because negative 3 plus 4 is 1. So a is 2, b is 4, and c is negative 3. 2, 4, negative 3. 2, 4, negative 3. Okay. So this integral was the integral of something over x plus something over, I don't remember the order, x plus 1, x minus 1. X plus 1, x minus 1. The integral of, oops, meant to put brackets, not an integral sign. The integral of that sum dx, and the a, b, and c were 2, 4, and negative 3. 2, 4, and negative 3. Well, for the first integral, you can bring the 2 in front. For the second integral, 4 dx over x plus 1, you can bring the 4 in the front. And for the third integral, you can bring the negative 3 in the front. But these integrals are straightforward. The integral of dx over x, that's ln of x plus 4. If that's u, then that's du. Now that's ln of x plus 1. Minus 3, if that's u, then that's du. Ln of x minus 1 plus c. So this is ln of x squared plus ln of x plus 1 to the 4th. X squared is always positive, so I don't need the absolute values. X plus 1 to the 4th is always positive. X minus 1 cubed is not always positive. Plus c. I can write this with 1 ln. This is an understood plus, so what I'm taking ln goes on the numerator. Plus, what I'm taking ln of goes on the numerator. Times x plus 1 to the 4th. Minus, what I'm taking ln of goes into the denominator. Plus c. of course, since what I'm taking ln could be negative, I could have just taken absolute value of the whole thing instead of just the denominator. Let's look at one more. Suppose you have the integral of x to the fourth over x minus 1 cubed dx. The degree of the denominator is 3. The degree of the numerator is not less than 3. In fact, it's more than 3. So either you do long division or you use another method. I mean, if you wanted to use long division, I guess the best way to do it is, say we let u equal x minus 1. So then du will be dx. So we have dx and we have the bottom to the third, but we need x to the fourth. Adding 1 to both sides, you get that u plus 1 is x, and we raise it to the fourth power. So what you have is x to the fourth, which is u plus 1 to the fourth. Dx is du, and the bottom is u cubed. So now you need to cube u plus 1 to the fourth. And I think using Pascal's triangle would be helpful. 1, 4, 6, 4, 1. This numerator is going to be 1u to the fourth plus, I'm using these 5 coefficients, those 5 numbers as the coefficients. 4u cubed plus 6u squared plus 4u plus 1. All divided by u cubed du. The first division gives me u. I divided that by u cubed. The next division gives me 4. The next one gives me 6 over u. Then I get 4 over u squared. And then I get 1 over u cubed. I wouldn't use partial fractions in this. First, I rewrite some of these. U plus 4 plus 6 over u can stay. But the 4 over u squared I'd write that way. And the 1 over u cubed I would write that way. The integral of u is u squared over 2. The integral of 4 is 4u. The integral of 6 over u is, 6 ln of u plus 4, add 1 to the power, divide by that power, add 1 to the power, divide by that power, plus c. This will be u squared over 2 plus 4u plus 6 ln of the absolute value of u minus 4 over u minus 1 over 2u squared plus c. And then I see that I let u be x minus 1. Okay, so it's x minus 1 squared over 2 plus 4 times x minus 1 plus 6 times ln of x minus 1 minus 4 over x minus 1 minus 1 over 2 x minus 1 squared plus c. And that would be the answer. And note that I did not use any partial fractions here. It could have turned out to be a partial fraction. Okay, possibly when I did this division, or in the u world, if I did that division, it is possible that I could have gotten, 3 over u squared minus 4u plus 4. And then I could use partial fractions there. But that's not what happened. This finishes the section on partial fractions.